Okay, alright, so we continue with the second method. Okay, I just short simple fits. Okay, the long name is simple fits point iteration method. Okay, so just mention simple fits, so that's mean you know lah. Okay, this method. Okay, so in general, basically the concept behind the simple fits method is we will rearrange. Okay, you have fs function. Okay, you will given in the question your fs. So in simple fits, okay, the first thing or the basic thing that you need to do is you need to rearrange, susun semula. So you need to rearrange and become or make it become. You will leave it one x at the left hand side and the rest you will bring to the right hand side like this. I mean, because this is fs, right? So means that they have a variable x inside there. So what we do is you will make it your x as a subject, and then the rest you will bring to the right hand side like this. Okay. Okay, so I give you example. For example, you have equation of x squared minus 2x plus 3 equals 0. Okay, so this is your function fx. Okay, this is your fx. Okay, so the next one is you want to make it your x at the left hand side and then gx at the right hand side. So then what we do next? Okay, so you have x here, x, so you can choose either one. Okay, for example, let's say the a1, you have x square here and then equal to, you bring this to the right hand side, so you have 2x minus 3. Okay, then you don't want to have x square, you want only have x. Okay, so what we do? Okay, it become 2x minus 3 over x. Okay, because we know that x square means it's a x times x, right? So means they have 2x here, so what we do is 1x you bring down here. Okay, maybe some of you will thinking like this, why not we do like this? Why not we also can do like this? Okay, so means that for this type of method, so you will have more than one possible gx. Okay, you have more than one possible gx. For example, like this lah, you have this one and you also can do like this. Okay, so which one that we will choose? Okay, you can choose any term of the x, but if you proceed with the calculation, maybe some of it will lead to answer and maybe some of it will lead to answer. Yes, both are we giving the answer, but maybe some of it or one of it will have complicated calculation compared to another one. Okay, you can see clearly here between these two, can you give me you can, in your opinion, which one that will contribute or which one that will lead to the complicated calculation? For me, I will see this one as a complicated things because they have a square root compared to this one. This one is more easy, I think, compared to this one. So this is more to instinct lah. I mean, yeah, maksudnya macam it depends on luck lah. Maksudnya maybe Fasha Sanda pilih this one, Siti Nurhaliza pilih this one. Tapi kalau pilih dua-dua ni akan dapat jawapan yang sama, cuma panjang atau pendek, masa lah. So the important here is your times to do the calculation. Okay, so basically this is the concept on how we use or we reduce from your function to this equation, x equal to tx. Okay, alright, so this one the first step, memang this one is the basic one. Okay, later on what we do next is just create the iterative. What's mean by iterative here? Okay, just now you have x gx, right? So later we will create the iterative equation, so you just put it as I plus 1 and xi. So we will use this formula, okay, or algorithm to iterate your calculation. Okay, alright, so I will show you the example here. Okay, they have no specific steps like the bisection, it's just simple like this. So okay, I will show you example. Okay, example. Okay, use simple fixed point, okay, to locate the root of, okay, fx equal to ex minus 3x squared equals 0. Okay, x squared equals 0. Accurate to within error 0.0001. Okay, use simple fixed point to locate the root of fx is exponential power of x minus 3x squared equal to 0. 3x squared, accurate to within the error. So when you can see here they have error, so that means they have a lot, they have more than one calculation that you need to do until you reach the error. Okay, until you reach the error. Okay, so this is the question. Okay, so the first thing first, what we do next? Okay. Okay, just now, this is your equation, right? Okay, so now we will reduce it become x equal to gx. Okay, so clearly that you can see that you will remain this term first. Okay, I will bring this term to the right hand side. So just it's become like this lah. Okay, then I will remain only x, one x here. So ex over 3 x. So therefore this is our x and here is your gx. Okay, so your equation or your formula will be like this. Okay, so you will using this formula to iterate your calculation. Okay, so to calculate it, okay, so same thing like the previous one, I just suggest you to use or to write it in terms of table. Okay, so this is I, okay, this is xi and this is error. Okay, so now this error is not xb minus sm lah. Okay, yang xb minus sm tu for bisection So now the error is xi minus 1, which is the current value minus the previous value. Okay, this is how we calculate error, right? Suppose the current one minus the old one. Okay, so for xi, the first one we use the x naught, and some question did not given or did not mention the x naught. So what we need to do is you will assume your x naught is equal to 1. Okay, so I repeat some question dia tak bagi pun x naught you apa, so you will assume your x naught equal to 1 kalau dia tak bagi. Okay, you will assume your x naught equal to 1, and then therefore for the first one is they have no error yet, belum ada error because the current value here is 1, right? So the previous value maksudnya yang sebelum ni lah, ada tak value? Tak ada, because kita memang we start with x naught. Okay, so they have no error yet. Okay, so when we proceed to xi, okay, so xi, to find this, okay, means x1 lah. Okay, because your I is 1. So how to get this one? How to get the x1 value? So you need to refer to this formula. So you just substitute lah 1. Maksudnya sekarang kalau you nak calculate x1, maksudnya e power of x naught. Okay, I think maybe some of you will get confused, but the concept is here like this. If you want to calculate xi, which is x1 right now, you want to calculate x1, so the formula inside here, you will use the value for the value that previous one, the value before it. So if you want to calculate x1, means that the value before it is x0. Okay, so the formula is using the equation that you have just now. So e power of x naught over 3x naught. Okay, so you can see that you want to calculate x1, so means that here is x naught. So what we have here, so e power of x naught, what is your x naught just now? So you can get it your x naught from the above, from the table itself, tapi you just refer to the above side. So your x naught here is 1, so e power of 1, okay, over 3x naught. What is x naught just now? Sama juga, 1. So means that you have e power of 3. So you can use your calculator, you will get 0.9061. Okay, you can use your calculator to calculate it. Okay, this one. Okay, right. So then, what's the error here? What's the error? So error, like I said before, the current value minus the previous one. So your current value is now 0.9061. The previous value is 1. So just minus lah, 0.9601 minus 1. So if you can see clearly that you will have a negative value, right? But please remember, please bear in your mind that error cannot be negative. That's why we have a modulus sign here. So it cannot be negative. So the error that you should get here is 0.0939. Okay, and then same thing, you check whether this error is already reached or equal or not with the error that given in the equation. Error that given in the equation just now is 0.0001, which is so too far yet. I mean, still jauh lagi kan. So you will proceed with the another iteration, another calculation. So for I2 means that you will calculate here is x2. Okay, you will calculate x2. Okay, so then e power of x what? x1. Okay, because why? You want to calculate x2, so means that you will use the value before it. Before, memang before, bukan x0. Okay, you must use a value before it, which is x1. The latest one that you calculate here is x1, right? And over with 3x1. So you do the same thing, e power of x1, so e power of 0.9061 over 3 times with 0.9061, and then you get the answer. Okay, use calculator to get the answer. So I want to highlight here that make sure you calculate carefully. Don't make it mistake, silly mistake. Please don't. Because of what? Because of actually it's not about on this method only, right? It's on the previous method also. If you calculate wrongly, so it will be affect the whole calculation. It will affect. So if you can see that if you have a wrong calculation on x1, let's say your answer will be wrong here, automatically your x2 will be wrong, because of you will use the latest value, the current value to get the next calculation. Okay, alright. Okay, so after you get x2, find out your error, and then if your error is still didn't reach yet the error given in the equation 0.001, so means that you need to do it the next calculation. Okay, so basically the answer or the iteration that you should do is until I equal to 4. Okay, I equal to, I think, yeah, I understand that you can't see it. Okay, I just read it for you, or maybe you can zoom this video later. Okay, so this is I equal to 4. So then when I equal to 4, you will reach, or you will get the error is 0.00003. They have 4 0 there, so means that it's more less than 0.001. So you can stop the calculation, and the final answer is on the last value of x, which is 0.91001. Okay, so this is how the simple fixed point iteration method process lah. I mean the steps. Okay, it's not, ni tak ada set yang specific lah. We just make it your function into x equal to dx, and then by using that formula or the equation, you will find out the next x, x1, x2, x3 by using that formula. Okay, so that one is for simple fits. It's simple, right? Simple, right? Okay, so simple. Compared to bisection, it's more simple lah. Okay, so we have another one method which is Newton-Raphson. So maybe I will continue that one in the next video. Okay, so see you later. Bye.